Hello, everybody. So today we are going to solve this daunting looking absolute value question from Manhattan GMAT, which was posted on GMAT Club and also on my WhatsApp group. If you're not part of the group and would like to join, look in the description below. And if you like this video and the solution, please do not forget to like and subscribe to my YouTube channel. It helps me a lot with YouTube and I'm able to provide more and more free videos as a result. Okay, so let's get started. We're going to use a technique that I demonstrated in one of my previous absolute value theory videos of breaking down the ranges. Before we go there, there is a simple way to solve this question, and that is just through putting values. However, putting values is never a sure shot method. So if you are strapped for time and cannot spend 2.5 minutes on this question, then absolutely you can use the picking values method, and we will demonstrate that quickly before we jump into the main method of solving questions like this. You're giving these absolute values in the expression, and in the first statement it is given that x is an odd integer. What you're also given is that x is positive, so you cannot take values less than 0. If it is odd, then negative is already out of the question. So x could be 1, 3, 5, 7, and so on. And if you quickly put these values actually in the expression, you will start getting 0 as the answer for all the values. I will not do the calculation here. Calculation is very straightforward. And even though you don't know what will happen way beyond, you would get this feeling that since I'm getting 0 for most of the odd values, that should be sufficient. And you would mark this as sufficient and you will not be wrong. That is a good extrapolation in this particular. In statement number 2, you are given x is greater than 6, but not given anything else about x. So if you start taking number 7, 8, everything, you will again start getting 0 as your answers, and you would feel that you have solved the question and this also is sufficient. And this is where you will get it wrong. Because x is not given to be an integer, you have to consider non-integer values of x as well, especially between 6 and 7, because x is given greater than 6. When you use values like 6.25, 6.5, you will see that the expression does not evaluate to 0, but a different number. And hence, sometimes it is 0, sometimes it's a different number. We cannot find uniquely the value of the given expression. So statement 2 is insufficient. The answer to this question is A. Okay, so quickly we solved this using picking values. As we saw that picking values is not a foolproof method, and it often results in us extrapolating a certain answer to get a wrong answer. So let's follow the approach that we learned in one of my previous videos with breaking down the expression based on their anchor points and then solving for different ranges. Okay, I've done some of the hard work here already, but it is very easy. So I would repeat, look at all the anchor points where each of the term in expression goes to 0. So x minus 3, so 3 is an anchor point. I have noted it down here. Similarly, 4, 6, and 7. I have noted down 0 just to anchor myself. I do that very often. This was part of my tutorial also, that always anchor yourself around 0 so that you are aware where the 0 is and where the negative numbers would lie. And then let's get started. So each of these terms, I have written them down, and I've also written down these signs separately, and I will apply them after I have opened up the brackets. The next step is to open up the brackets. So let's see how we are going to do that. So x minus 3. So x minus 3 and the absolute value expression, which means this will always be positive. When x is greater than 3, for example, 4 minus 3 is 1. So on this side, this is x equal to 3. On this side of the number line, it will be x minus 3. On the other side of the number line, this expression will be negative of x minus 3 because x is less than 3, which means x minus 3 is negative. So let's quickly write that. Similarly, we look at x minus 4. X minus 4 would be greater than 0 when x is greater than 4, but negative of that when it is less than 4. So we can quickly write, there is also this negative sign, but I promise we will come back to it, but not now. X minus 6, we can quickly do that as well. And x minus 7. All right. So we are here. Okay, so we are here. We opened up all the expressions. We have forgotten a couple of things here. So there is a 2 in multiplication of x minus 4 everywhere. So before I go anywhere, let me just add this 2 to the expression so that I do not forget it. Same here. And now let's take care of the negative sign. So because this is negative sign, I'm going to change the signs on each of these terms. So this will become positive, positive, negative, negative, negative. So we have these expressions now. As you can clearly see, there is a minus x here, there is a plus 2x, there is a negative 2x, so these would cancel. There is a minus x and plus x here. These two will cancel. And if you actually solve this equation, and let's quickly solve it. All of these terms are in addition at this point, so this will become minus x plus 3, 2x minus 8, minus 2x plus 12, and x minus 7. The x and x would cancel, the 2x and 2x will cancel, and what you would find is even the 15, 12 plus 3, 15, and 8 plus 7 is 15. So 15 and 15 would cancel. So this will equate to 0. So for any number below 3, this expression evaluates to 0. Similarly, when you start looking at this expression would equate to something like 2x minus 6. I will leave the actual algebra to you. It is very straightforward. Similarly, this expression would evaluate to 2 minus 2x plus 10. Again, I will leave the algebra to you. All you have to do is just add these terms properly. Between 6 and 7, it will lead to 2x minus 14, and more than 7, again, just like less than 3, it will evaluate to 0. So these are your ranges. You haven't started looking the statements yet. You have only solved for this expression. You have opened up the braces and figured out what the value of the expression would be for each of the relevant ranges. Now let's start looking at the statements. So x is an odd integer. So if an x is an odd integer, that first of all, x is given to be positive, but odd integers are positive. So you would take between 0 and 3, you would take 1 and 3, let's say. For each of that, it will evaluate to 0. So that is our first value of x, or the expression that we get. There is no odd integer between 3 and 4, so we can forget about this range. There is one odd value between 4 and 6, and that is 5. When you put 5 here, you get minus 10 plus 10, so you get 0 again. So that is another value of the expression, which comes out to 0. No odd values between 6 and 7. At 7, you would get the expressions 2 times 7 minus 14, which is 0. So the evaluates to 0. And then you take any number over 7, you are already getting a 0. So you are always getting 0 as the answer. So this is sufficient, as you can see, because you get a unique value of this expression. When x is given greater than 6, now you don't make the mistake of not taking non-integers. You are seeing that between 6 and 7, the expression evaluates to 2x minus 14. X is not given to be an integer, only that it is positive. So at this point, you have to consider some values here between 6 and 7 to evaluate, and you would see that they will not evaluate to 0. So values here will not evaluate to 0, and values 7 and above will evaluate to 0 for x is greater than 6. Hence, you are not getting a unique answer. So this is insufficient. A couple of other points. This method is definitely a longer method, but it's very systematic. Once you start practicing, it doesn't take too long. I'm very confident that you can solve the question within 2 minutes, but you have to practice. If you don't get it the first time, it is okay to kind of keep doing it. For the same question, do it a couple of times so that you get used to the pattern, you get used to the steps, and then you get used to the systematic approach that we have outlined here. If you have any questions, you know that I respond to all the questions, so please put it in the comments and I will respond to you as soon as I can. If there are questions that are really good about this video, I will create a personalized video to answer that question. Do not forget to like the video if this was helpful, and subscribe to my channel for more such free videos. Thank you very much. I hope this was helpful.